This video we're going to transition from looking at the function to analyzing with the derivative. First of all, we have a graph of f of x. We're going to find the absolute max. Well, the absolute max is simply the highest place on the graph. That would be at B. The absolute minimum is simply the lowest place on the graph. That would be D. Local minimums are spots that are lower than any of the stuff around it. So certainly D and S would be local minimums. You could also classify A maybe as a local minimum, but I usually just think about the interior points. So I'm just going to stay with D and S. Okay. Local maximums, the points highest of the stuff around it. So B and E. And again, maybe you could make a case for D, but I'm going to just focus on the interior points and just have B and E. Critical points are anywhere the derivative is 0 or undefined. Well, here the derivative is 0. Here the derivative is 0. Here the derivative is undefined. Here the derivative is 0. It's not a max or min, but it is horizontal. And here it's 0. So I've got B, D, E, R, and S. And finally, the spots where the derivative doesn't exist, we already said at E there's a cusp, so the function is not differentiable. Now, I want to use the graph of f prime to get the critical points. Well, remember, critical points are where the derivative is 0 or undefined. So we have a graph of the derivative. Let's list the critical points. At -4, the derivative is 0. At 3, the derivative is 0. And at 10, the derivative is 0. And at x equals 0, the derivative is undefined. So again, you got to pay attention to what we've actually got, what we're using. The derivative is 0 or undefined at -4, 0, 3, and 10. Now, we're going to classify each in the original function. Okay? How we're going to think about this is that let's start with -4. The derivative is negative, and then the derivative becomes positive. What that means about the original function is it had a negative slope and then a positive slope. Or it went from decreasing to increasing. Well, if I tell you a function was decreasing and then begins increasing, you know that that function had a minimum. Well, let's look now at 3. So the derivative changed from positive to negative, meaning the function changed from increasing to decreasing. Well, if a function was going up and increasing, then decreasing, you know that function had a maximum. At 10, the derivative was negative, then positive, so the function was decreasing, then increasing. So think of functions decreasing, then increasing. You know that that was a minimum. And at 0, it didn't change signs. It just is an undefined spot. So 0 would represent neither a max nor a min. So we're going to use that same idea, and I'm sorry this gets a little messed up whenever I switch to italics, but we're going to find the critical points and classify them. Okay, so the derivative, let's start with that. Okay, would be x squared plus 5x minus 6. Well, since we're going to need the critical points, I think it will be easiest to factor this. Okay? And you think, well, where is that 0? At negative 6 and positive 1. These are our critical points. Now, it's a parabola, so remember, a critical point is anywhere the derivative is 0 or undefined. But the derivative is not going to be undefined here. It's only going to be 0. Now, we're going to classify in the original function. So let's go over here. Let's do a little sign analysis on our derivative. I'm going to put in my critical points, like that. And I'm going to do a little sign analysis of my derivative like you did in pre-calc. So first thing, I'm going to pick a number less than negative 6. So, negative 10. Well, negative 10 plus 6 is negative. Negative 10 minus 1 is negative. A negative multiplied by a negative is positive. So the derivative in that section of my sign analysis is positive. Well, now pick a number between negative 6 and 1, maybe 0. 0 plus 6 is positive, but 0 minus 1 is negative. A positive multiplied by a negative is negative. Well, let's do the last section. A number bigger than 1, maybe 10 again. 10 plus 6 is positive. 10 minus 1 is negative. 10 minus 1 is positive. So positive multiplied by positive is positive. So here's what I know. The derivative changed from positive to negative at negative 6, meaning the function changed from increasing to decreasing, making this a maximum. At positive 1, the derivative changed from negative to positive, meaning the function changed from decreasing to increasing, making 1 a minimum. Okay, so we know this is a max, we know this is a min. Very often in calculus you're asked to justify that using calculus. Your justification would simply be that here the derivative f prime changed from positive to negative. And here, the reason you knew it was a minimum was f prime changed from negative to positive. Okay. Now, find the absolute maximum and minimum. I just wanted to remind you of what's called the candidate test. Remember, the candidate test says you should plug in the critical points, so f of negative 6 and f of 1 to the original function, and you should plug in the endpoints to the original function and see which gives you the biggest and smallest values. And I'm not going to do that in the interest of time. You could plug those in your calculator. But I do want to point out the absolute max and min, we're using the original function. We're just saying, where is the function at its highest and lowest points? But here, when we're classifying with the derivative, we are analyzing the derivative, saying where the derivative is positive, the function's increasing. Where the derivative is negative, the function's decreasing. So you got to kind of make sure you know what exactly you're doing and where you're plugging things in. To find the critical points, we use the derivative, set equal to 0, or figure out where it's undefined. And to classify, we do sign analysis. But to do the candidate test, we plug in our critical points and our endpoints to the original function, because we're actually trying to know the original function's values to know where it is at its highest and lowest point.